Okay, let's finish up the intro to probability. So the last thing that we have to talk about in the intro is a couple of probability rules. So we're going to look at the rules. And the first rule says this. The first rule says that the probability of an event, so P of E, will always be between 0 and 100%. So all probabilities are always between 0 and 100%. So we won't have any negative probabilities. So there won't be any negatives. So there's no such thing as a negative 20% chance something's going to happen. And we also don't have probabilities over 100%. So there isn't a 125% chance that something's going to happen. The highest is 100 and the lowest is 0. But we also have to be very careful with 0 and 100. They have to be absolute sure, okay, on 0 and 100. So the probability of winning the lottery is, I think it's 0.00001%. So that's a bunch of zeros before you ever get to the 0.00001%. But we would never round that to 0 because there still is a chance that you could win the lottery. So we go out as many zeros as we have to in order to get to the actual part of the number that's significant. In order to be 0, it has to be like it cannot happen. So what's the probability that you roll a die and you get a heads? So there's no heads on the die, so that absolutely cannot happen. So that is 0%. And the same thing with 100%. So the example I use there is, what's the probability the sun comes up tomorrow? And we would like it to be 100%, but it's actually not. I'm really hoping it's like 99.99999999999, but it's actually not 100%. The sun is a star. Stars can blow up. Today might be the day that it blows up. There's a really teeny weeny chance, so the sun probably will come up tomorrow, but it's not 100%. So in order to be 100%, it has to happen. So what's the probability that you roll a die and you get something less than 7? So because all the numbers on the die are less than 7, if you roll a die, you're definitely going to get something less than 7. So that would be 100%. Okay, so probabilities are always between 0 and 100%, and we're being careful about the 0 and the 100. The next rule says that the sum of all of the probabilities in an experiment is equal to 100%. And what that means basically is, if you're going to do an experiment, you're going to get an outcome. So the probability that when you do the experiment, something is going to happen. So if you use all of the events in the sample space and you add them all together, the probability is 100%. So basically it's saying you roll the die and you get something between 1 and 6. Well, that's every outcome in the experiment. So that is that is 100%. Okay, and mainly we don't use this one so often. It's just more that it's kind of a rule that says probability works. If you do an experiment, you get a result. All right. Now our last rule comes with a little bit of writing, so we have to kind of get to it. And it's the complement rule. So it actually has a name. And we say the complement of an event, written E to the C, okay, E complement or E to the C, is So the complement of an event is basically everything you don't want. If the event is what you do want, then the complement is everything else. So if you're looking at a die, and the event is that you want to get an even number on the die, then the complement is going to be everything else, which would be the odd numbers. So we would say E complement is getting an odd number on the die. So if E is what you want, E complement is what you don't want. And the rule there looks like this. It says if you take the probability of E plus the probability of E complement, you will get 100%. So if you take everything that you want and you combine it with everything you don't want, now you have everything, right? You have all of the outcomes, what you want and what you don't want. So together that makes 100%. Now, we don't normally use this rule in this format. Normally what we do is we subtract this guy to the other side. So the rule actually looks like P of E equals 100% minus P of E complement. So if you take away what you don't want from 100%, you have the total, 100%, and you take away what you don't want, you'll be left with what you do want. Okay? And just a little example of that. Would be, let's say, there's a 41% chance you pick your nose today. Find the probability you don't pick your nose. Today. So you're given a bit of information. We know that there's a 41% chance you do pick your nose, but I'm interested in that you don't pick your nose. So I'm interested in the complement. What we don't want to happen is the complement. So if we want to find the probability of not picking your nose, we can take 100% and we can take away what we don't want, or the probability of picking your nose, and that will leave us with 59%. So if there's a 41% chance you pick your nose, there's a 59% chance that you don't pick your nose. Okay, so 3 rules that we carry with us as we do probability, but that ends it for the intro to probability. Okay, I will see you for the next one. Have a good day.